Welcome to section 3.5. Today we're going to be talking about equations of lines. There are very many different forms of how you can write the equation of a line, so we're going to talk about those forms and how to transform between those forms. Alright, so objective number 1 is just to use the slope-intercept form to graph an equation. We talked about slope-intercept form in the previous section. Right, but again, to recap, slope-intercept form is y equals mx plus b, m being the slope of your line, and the point 0, b being your y-intercept on that y-axis. All right, so if you're going to use the slope-intercept form to graph your equation, the first thing you're going to do is you're going to identify your slope and your y-intercept. And then you're going to begin by graphing your y-intercept first. So you are going to start right here at this y-intercept, which in this case is 0, -2. And then you're going to use your slope. Use your rise over run. Now we have a positive slope, so we know we should be going up the mountain. So we're going to go up 3 units, and then we're going to go to the right because we're going to go up the mountain. So up 3 over 5, and then I would put that second point, and then you can draw in that line. Right? It's just as simple as that. Start with your y-intercept, use your rise and your run to plot another point, and then connect those two dots. This is why slope-intercept form is very popular when it comes to graphing, because it is very straightforward. As long as you have a nice pretty fraction for your slope or a nice whole number, and your intercept is a nice whole number, this is a very easy. If you get some fractions for your slope, for your intercept, it can get a little tricky. All right, so if you need to use the slope-intercept to write an equation of a line, so here we go, let's try a couple of these. All right, so find the equation of the line with a y-intercept of -2. All right, so here, that is your b value, right, your -2, and a slope, and it tells you your slope, m. So very simply, just start with your form, right, slope-intercept form, it told you right there. And then just fill stuff in. So we can fill in the slope, which is 3/5, and fill in the intercept, which is -2. So there would be your equation. So you can use that information to also easily write the equation if you are just straightforward given your slope and your intercept. All right, you may not be given the slope and the intercept, so you may be given the slope and a point. So let's talk about how you write the equation if that happens. All right, there's a great form called point-slope form, and you may not have used this in high school, but you will definitely use it, especially when you get to calculus. I use this a lot in my calculus class. All right, point-slope form, which is actually a derivative of the slope formula, which is kind of cool, but this is also a way. So if you are given the slope m, okay, there's your slope right there, and then you're given one point, so x1 and y1. So here's your y1 and here's your x1. All right, you can just plug it right into that formula. You will find that, especially in the sciences, you'll use this quite a bit. All right, so find the equation of a line with a slope of -2 that passes through -11, -12. Write the equation in slope-intercept form and in standard form. Okay, so notice we're starting with a slope and a point. So it makes sense for us to start in point-slope form because that was the information we were given. So I'm going to start by writing point-slope form. I'm going to fill in what I know. So I know that the y1 is going to be subtracting a -12. My slope is a -2, and then it's x minus the x part, which was -11. So I'm going to clean that up a little bit. So it's going to give me y plus 12 equals -2 times x plus 11. All right, so there is your equation in point-slope form. Now, it says it wants you to write the equation in slope-intercept form and in standard form. So notice that in slope-intercept form and in standard form, there are no parentheses. So the first thing I'm going to do is I'm going to get rid of those parentheses. All right, so I've used the distributive property to get rid of the parentheses. If you want to go into slope-intercept form next, I probably would because notice the y is by itself, so all I have to do is subtract 12 from both sides. So you get y equals -2x minus 34. So there is your slope-intercept form. And then if you want to get into your standard form, notice you need the x's and the y's all on the same side. So I would take this and add it to both sides. So here we're starting in slope-intercept form. All right, so I'm going to add 2x to both sides, and I get 2x plus y equals negative 34. There is your standard form. All right, so we started with point-slope form. We converted into slope-intercept form, and then we converted again into standard form. All three of these lines are exactly the same line. If we graphed them, they would all be exactly the same. They're just three different representations of how we could write the equation for that line. You do need to be familiar with all three of these for the test. And mostly because when you get to your science classes, you're going to use all three of these for different things. Like I said, I know I use point slope a lot in calculus, so all three of these will serve some purpose at a different point in a different class later on. All right, you could also just be given 2 points and be expected to find an equation. All right, so if this is the case, this is your x1, this is your y1, this is your x2, this is your y2. Notice they do not give you slope at all. Okay, so that's the first thing I'm going to start with. We always need the slope. All right, so I'm going to do y2 minus y1 over x2 minus x1. And I get negative 1 over 10. So my slope is negative 1/10. Neither of the points they gave me were a y-intercept. So that's kind of a bummer. But the good news is I've got a point and I've got a slope, so I can use point-slope form. So you just have to decide which point you want to use with your point-slope formula, with your point slope. So I'm going to use this one right here. It doesn't matter which one you use. You should get the same thing. So it's going to be y minus negative 1 equals slope times x minus x part. All right, so when I clean it up, y plus 1 equals negative 1/10 x minus 6. Okay, so there is point slope form. It wants us to write this in standard form. So that means we want standard form, remember, is ax plus by equals c. So I need to clean this all up. First thing I'm going to do, and this is optional, is just I don't like fractions. So I am going to use that trick from solving equations where I'm going to multiply both sides by the least common denominator to get rid of all the fractions because I prefer whole numbers. So this will give me 10y plus 10 equals, notice the 10 times the negative 1/10 will just give me negative 1. So that's kind of nice. So I get 10y plus 10 equals negative x plus 6. Again, when you distribute that negative 1. I need to get all the x's on this side with the y's, so I'm going to add x to both sides. So I get x plus 10y plus 10 equals 6, and then I'm going to subtract 10 from both sides. So I get x plus 10y equals negative 4. So there is my equation in standard form. Now there are many ways that you could come up with standard form. This is just one of the possibilities. I just don't like working with fractions in general, so I usually do this little trick a lot to get rid of all my fractions. If you are curious as to how that trick works, you can go back on my YouTube channel and look in my 22 course under section 2.4. So chapter 2, section 2.4, I talk about that trick of how to solve equations using this, it's called clearing the fractions. Or if you wanted to, you could just go on YouTube and type in clearing the fractions. And they talk about that. But that's a favorite trick of mine because I like to deal with whole numbers and not fractions. So there you go. That is converting. So we took 2 points, we found the slope, we put it in point slope form, and then we transformed it into standard form. Again, a lot of writing for these problems, so you really have to know what you're doing. You have to know all the forms, you have to know how to manipulate, have to know how to solve equations. So there's a lot of information contained in this section. All right, again, they are going to talk about vertical and horizontal lines as well. Luckily, these are probably the easiest ones to do. I like these. So find the equation of the vertical and horizontal lines through this point. Now, vertical is always x equals a number. And if you look at this point, the only x value that they give us is negative 7. So the equation that is vertical would be x equals negative 7, and you are finished. Horizontal, same thing. Horizontal is always y equals a number. And if you look at this point, there's only one number, -2. So y equals -2. So there are your vertical and horizontal lines through that point. Notice how straightforward it was, okay? But you had to know that vertical lines are always x equals a number and y equals a number. So again, this retaining that basic information from previous sections is going to be really important. All right, find the equation of a line parallel to y equals -3. Now, I'm going to stop right there. My line y equals -3. This is a horizontal line. If it's parallel, if I'm looking for a line parallel to that, it must also be a horizontal line. So it's going to be y equals a number. And if you look at this point, that tells you the number you need. So y equals 4. So y equals 4 is the line that is parallel to y equals -3 that passes through the point 10, 4. Again, lots of retained information that you have to remember. You had to remember horizontal lines. You had to remember what parallel meant. So definitely retention of old information is going to be important. All right, find all three equations of the line that is perpendicular to 2x plus 3y equals -6 and passes through point 1, -2. So a lot of information going on here. Okay, first thing I know is I'm going to need a slope, and it's going to come from this line right here. Okay, this line, and it's going to be perpendicular. So once I find this line, once I find its slope, so let's see, I'm going to subtract 2x from both sides. And I get -2x minus 6. And then I'm going to divide everything by 3. All right, so there's the equation of the line in slope-intercept form. Okay, it wants it perpendicular, right? Perpendicular to this. So this means that the perpendicular slope is going to be positive 3/2. All right, so we now have a slope of positive 3/2, and it needs to go through this line over here. So I'm going to put this in point slope form, right? Y minus y1 equals slope times x minus x1. So y minus the y part equals the slope, which is positive 3/2, times x minus the x part of that point. So I get y plus 2 equals 3/2 times x minus 1. So if they asked for just point slope, we would be done right here. But this one asked us to find all three. All right, so there's the first one, right? Here's our point slope form. If I wanted to get into slope-intercept form, first thing I'm going to do is I'm going to get rid of the parentheses. All right, I got some fractions. So maybe if you don't like the fractions and you want to divide at this point, you can. It doesn't matter. There's lots of ways to go about doing this, but because I'm looking for slope-intercept in particular, next I'm just going to keep going here. So y equals 3/2 x minus, all right, 3/2, 2 would be 4/2. So instead of 2, I'm going to write 4/2. So -3/2 minus 4/2 is -7/2. So there is my slope-intercept form. All right, so there's the second one. And the last one they want is standard form, where you put the x on this side. So -3/2 x plus y equals -7/2. And there's lots of ways to write this. This isn't the only correct way, and it depends on the textbook that you use as well. Like my textbook, when I took algebra, said that the numbers all had to be whole numbers. They couldn't be fractions. So my textbook would have told me, okay, you're going to take this, multiply everything by 2. So you get -3x plus 2y equals -7. So notice nice, pretty whole numbers. And my textbook also said that the number in front of the x, the coefficient of x, had to be a positive number. So it would have wanted me to change all those signs. So that would have been the correct answer according to my old textbook. So it's really important at this point that you really know the definition that your textbook uses. This textbook that we're using uses this definition right here, would be a perfectly acceptable answer. My textbook growing up would have said this one. So they're both correct, just depending on which definition your textbook uses for standard form. Personally, I just like the answer with all the whole numbers in it because I'm not a big fan of fractions. So this one, very lengthy problem. You had to go through all the steps, you had to know all the forms, and you had to perform all the algebra on top of it to manipulate these equations. So these are probably going to be the most challenging. So those I would definitely pay some extra special attention to when you're practicing your homework. All right, using point slope form to solve problems. So you are going to get word problems that do involve point slope form, or other forms of the line for that matter. All right, so in 1997, Window World had 50 employees. In 2012, the company had 85 employees. Let X represent the number of years after 1997, and let Y represent the number of employees. Assume that the relationship between years and numbers of employees is linear, so there's going to be a line. Write an equation describing this relationship. All right, and then use the equation to predict the number of employees in 2007. Okay, so the first thing we have to do is we have to actually find the line. Now, we need 2 points, right? We don't have a slope here or anything, so we need 2 points. And this information at the beginning is actually going to tell me that right here. Okay, so we're given a year and a number of employees, a year and a number of employees. This is your X, this is your Y, okay? And the X is the number of years after 1997. So this year right here is actually X equals 0, right? Because 1997 is 0 years after 1997. 2012 would then be X equals, let's see, 97 would be 3 years to 2000, so that'd be 15. So our 2 points are going to be 0, 50, and 15, 85. So those are going to be the 2 points. So let me get a new slide here so we have some space. Okay, so here are 2 points, 0, 50, and 15, 85. So we are going to use those to find the equation. All right, so first thing I need to do is find slope. And I'm getting, this will be my x1 and y1, and this will be my x2 and my y2. So y2 minus y1 over x2 minus x1. So this is when I always have to have a calculator because I always mess up the easy things. 85 minus 50 is 35. 35 over 15 can be simplified. That's 7 times 5, and this is 3 times 5. So the 5s will divide out, and I'm left with 7/3. So there is my slope. Right, and notice they gave you the y-intercept. So it makes perfect sense for you to go right to slope-intercept form, right? You don't need to go to point slope form or just, again, look at the information it gives you, very important. So y equals 7/3 x plus 50. So this is the equation of the line that's going to model the growth of employees in this company over the years. All right, so the second part of the problem is we're going to use this equation and we're going to predict the number of employees in 2007. Now, 2007, remember, we're doing years after 1997. So this would mean that x equals 10, right? Because 2007 is 10 years after 1997. So you are going to take your equation and you are going to plug in x equals 10. All right, and again, I'm going to use my calculator just because I don't trust my brain anymore. All right, so I plugged it in my calculator and I get 73.333333. Okay, now you can't have 0.33333 of an employee, so you have about 73 employees, and that's what that little squiggly equal sign means. This means approximately. We have approximately 73 employees in 2007 based on this model. All right, so you will use slope-intercept form in word problems quite a bit. So again, go back and practice a couple word problems as well. All right, so that is the end of this section. You're free to go do your homework, and we will see you for the next section.